Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Chemistry Rate of Reaction Factors. So last time we talked a bit about rate of reactions and how they work. Today we'll be looking at the factors affecting rate of reaction, so how we can increase the speed of reactions, how we can increase the rate of reactions, and how we can decrease the rate of reaction. So, without further ado, let's get started. So, first of all, again, I need to remind you, how do we get a reaction? Well, collision theory tells us how we get a reaction. So, in order for two particles to react, they need to collide into each other with enough energy. So the rate of reaction is essentially how many successful collisions we are getting per second. And this is important because this forms the basis of pretty much everything I'll be explaining today. So, let's do this. So the first factor that affects rate of reaction is right here, and that's temperature. Because particles move around in a solution or in a gas or even in a solid, they move around, and the energy that they carry is dependent on the temperature they have. So if we heat the particle, so if the particles are cold, right here, they don't move around with much they don't carry much kinetic energy. They don't move very fast. They don't move with much energy. So there isn't many successful collisions happening. However, when we heat up the particles, now they gain more energy. Now they're moving around more, and they are colliding with each other more because they are moving around more. And also, they collide into each other with greater energy, with greater impact. So there is more successful collisions per second in a hot substance than there is in the same type but cold substance. So temperature increases the one, frequency of collisions, and two, the energy that the particles collide with. So therefore, altogether, the increase in temperature equals increase in the frequency of successful collisions, which leads to increased rate of reaction. So what's the next factor to discuss? Well, the next factor to discuss is concentration or pressure. So if we have a low concentration of particles, then there are very few particles in a given amount of space. So say if we have all the particles in a bottle, if there is a low concentration, we do not have very many particles in that bottle. Now, if we have a high concentration of particles in the same size bottle, then in the same amount of space, we simply have more of the particles that we are interested in. So you can already probably see how increase in concentration will give us an increase in rate of reaction. Because if we have very few particles in a given space, then they are pretty unlikely to collide with each other. They're moving about randomly, but because there isn't very many of them, they're unlikely to collide with each other. So the frequency of successful collisions is low. Whereas if we have a certain space, like the bottle I was talking about, and there is lots of particles in there, and they are all moving around randomly, then suddenly we have a higher chance of particles colliding. Purely mathematically, we just simply have a higher chance. And therefore, the rate of successful collisions is increased. So simply, we are increasing the rate of reaction this way. Now, pressure works the same way. So when it comes to pressure, if we pressurize a certain amount of particles, the same number of particles, if we put them under pressure, then in the smaller space, we have the same amount of particles, but we're cramming them into a smaller space. So in that way, we are also increasing the rate of successful collisions. So the third factor that affects the rate of reaction is surface area. So if we have a solid that is in a sort of one big chunk, then that will have relatively low surface area, as opposed to if we have a solid that's split up into smaller chunks. With the same solid that's broken up into smaller chunks, it simply exposes more of that solid, so we have a higher surface area. So the way this works is that in order to react with that solid, a particle needs to come to that solid, and it can only react on its surface area. It cannot go inside it. It has to react on the surface area. So if we have a low surface area, then there isn't many places where that particle floating around could react with the said solid. Whereas if we have a high surface area, then we have lots of options. We have lots of spaces where that floating particle could sit down and react, essentially. So if the surface area is low, then the rate of successful collisions is low, and therefore rate of reaction is also low. Converse is true for high surface area, where those particles are very likely to collide with some surface area of a solid that's free, and therefore react. So higher frequency of successful collisions, and therefore higher rate of reaction. So that's the third factor that affects rate of reaction. Now, the final one we need to discuss is the presence of catalyst. So as we know, catalysts increase rate of reaction. You probably knew that. So how do they do that? How does that make sense? Well, the catalyst doesn't necessarily increase the frequency of collisions, but it does increase the frequency of successful collisions. And I will explain this, what's going on here. So here I drew up a little graph, the reaction graph, where we have energy in y-axis, progress in x-axis, and the black line is the original reaction, and the red line is the catalyzed reaction in the presence of catalyst. So here we have reactants, and here we have products. So as you probably remember, this is an exothermic reaction, but first we are actually going up here. We are taking up that energy, and that is activation energy, which we discussed in another video. So that's the activation energy. And what catalyst does essentially is it lowers the activation energy. So we require less energy, less activation energy to commence the reaction, to start the reaction. Well, this actually goes down to the molecular level as well. So in the original reaction, molecules need to collide with a higher energy. They need to collide harder to be able to actually react. Whereas in the presence of catalyst provides them another route, another pathway that they can take that requires lower activation energy. So in the presence of catalyst, molecules need to collide with much lower energy in order to be able to react. So now we got this. So now catalyst molecules need a lot of energy to react. Catalyst molecules need a little energy to react. Now if we think about all these molecules floating around in the space, some molecules float around with high energy, some molecules float around with medium energy, some with lower energy, and then the temperature is kind of an average energy. So they're sort of floating around with differing kinetic energy levels. And if we lower the activation energy required to start the reaction, then that means that more molecules in that space will actually be able to react. Considering that all of them have slightly different kinetic energies, more of them will be able to satisfy that energy requirement. So we are increasing the number of the frequency of successful collisions by adding a catalyst, and that's how it works. So this is it for today, guys. I hope you liked this video. If you think this video helped you, give me a thumbs up, don't be shy. If you want to see more videos like this on GCSE chemistry, GCSE biology, GCSE physics and maths, as well as some A-level biology and biomedical science, make sure you hit that subscribe button below, don't be shy. If you have any questions, don't be shy, just ask in the comment section. I will get back to you as soon as possible. And thank you for watching my videos. I really appreciate this, seriously guys. Thank you very much, and see you next time.